Hello guys, welcome to Lenovo PC. Laptops with similar specs might differ greatly in performance. In our last video, we talked about CPU and GPU. This time, it's all about hard drives. If you find the information in today's video useful, please feel free to like this video, subscribe to this channel, and ring the bell so that you don't miss out any future specs talk. Hard drives are an essential part in maintaining data. There are two types of internal hard drives: hard disk drive 2.5-inch and 3.5-inch, solid-state drives 2.5-inch, and PCIe SSD. Hard disk drives are cheaper and you can get more storage space. Solid-state drives, however, are super faster, lighter, quieter, more durable, and they use less power. Solid-state drives are now the rule in mainstream laptops. There's also SSD and HDD combo for some products. But as we know, hard disk drives are bigger and heavier. This design will add more thickness and weight to the laptops. That is not good news for laptops with higher internal space requirements. So don't just think 1 TB or 2 TB storage is a good option. You also need to check out what type of hard drive it is. Of course, similar solid-state drives may vary a lot in performance. There are many factors that affect SSD performance. In terms of hardware configuration, there are three main parts: interface, bus, and protocol. Let's first talk about interfaces. In a laptop, there are mainly two types SSD: M.2 SSD and 2.5-inch SATA SSD. M.2 SSD takes up far less space and are the mainstream connectors on laptops. It supports SATA and PCIe, these two buses. So what are the buses? In computer architecture, a bus is a communication system that transfers data between components inside a computer or between the computers. For hard drive, it's a transmission path that transfers data to and from the host computing system. Currently in a laptop, we have SATA bus and PCIe bus. PCIe has an edge over SATA in the future, while SATA is slowly being phased out. Protocol is a set of rules or procedures for transmitting data between electronic devices, such as computers. In the Internet Protocol Suite, it's equivalent to the application layer of communication protocols. For now, SATA uses the legacy protocol, AHCR, to connect the CPU subsystem, while PCIe matches the NVMe protocol. The mainstream SSD configuration is able to deliver high performance and optimize power consumption. Interface bus and protocol determine the interface speed bandwidth between host and SSD. The latest interface, SATA 3.0, was launched in 2009, and it can transfer data at 300 MB per second. For consumer SSD, the theoretical speed of a PCIe Gen 4x4 can reach 8,000 MB per second, and it supports multiple channels. It is still developing iteratively, and PCIe Gen 5 will come soon. SATA, on the other hand, is no longer updated. When it comes to buying a laptop, we should pay special attention to SSD interface and its bus type. For high-performance SSD, try to pick a PCIe SSD. However, the performance and reliability of a PCIe SSD, which also supports NVMe protocol, will still be quite different. For example, the same M.2 2280 SSD, Samsung 980 Pro SSD 1 TB, costs around $229. But with the same capacity, some brands cost even less than half. This huge price difference is not the only thing that distinguishes it from others. So what are the benefits of a top solid-state drive in your laptop? Let's take a look at the structure of SSD. The performance changes are impacted by NAND flash, controllers, and other SSD components. NAND flash is one of the core components of SSD, the medium or data storage. Common types of NAND flash storage are SLC, MLC, TLC, and QLC. As for the performance and service life, LLC is greater than MLC, TLC, and QLC in turn. The prices are in the same order. With the development of flash memory technology, laptop products have changed from HDD to SSD storage. At present, TLC is the mainstream choice of laptops as it delivers the best price-to-performance ratio we have seen. With the improvement of QLC flash memory technology, QLC technology took off and became more widely accepted, offering consumers more storage space at lower prices. The controller can be referred to as the brain of SSD. It communicates with the host externally and NAND flash internally. The external communication channel is generally called a LAN. It usually has 2 or 4 LANs, while the internal communication with NAND flash is called channel. It usually has 8 or 4 channels. We usually apply those 8 channels to high-performance SSD. DRAM is used to store the flash mapping table FTL, which can understand as a directory of a data address of SSD. SSD with DRAM cache buffer delivers better random read and write performance, and it can put more data on DRAM for caching. This part also applies to some high-end SSD. However, it may be difficult for us to know much about SSD in laptops, so we have 2 simple ways for you to select SSD. First of all, choose high-quality SSD manufacturers. At present, the manufacturers that can independently produce NAND flash memory particles include Samsung, Micron, Hynix, Kaixia, Western Digital, etc. These are the Tier 1 SSD manufacturers. A second better option is to use original SSD from top-tier laptop brand. This is because top-tier laptops not only use the original NAND flash SSD, but also have a relatively higher level of NAND flash. Unlike personal purchase, laptop manufacturers purchase from SSD manufacturers in a customized manner. SSD products are subject to stricter quality standards and stress tests for reliability and compatibility. As for quality standards, here are a few keywords for you to know better. First of all, durability. It mainly refers to the ability of SSD to repeatedly write and erase data. This depends on the NAND flash itself. For example, Lenovo Legion, Yoga, and IdeaPad series are guaranteed to write 20 GB of data per day for about 10 years. The second one is continuity. That is the length of time data can be stored in SSD, such as 5 years or 10 years. The third one is stability. As we know, the metal used in SSD M.2 interface is gold, which is usually about 0.1 micrometer in industry standard. Lenovo takes up to 0.72 micrometer for stronger signal stability. It's way above the industry standard. About the test strategy part, for example, the SSD adopted by Lenovo will be tested 100%. Every SSD will be tested according to our own test standards and logic before deciding whether or not to adopt it. Besides the conventional reliability test, environmental pressure test, and mechanical pressure test, we have also developed some exclusive simulation tests on real use scenarios. The test is conducted to simulate use scenarios for 3 months after booting up, aiming to eliminate some low probability problems on SSD as much as possible. We also do compatibility testing after mass production, and every laptop goes through a complete compatibility test before leaving the factory. Lastly, SSD of the same brand and model, the larger the space, usually the longer service life, and the faster the writing speed. Faster means more operation units and a larger cache unit of LSA, so it can write more data in parallel and have a longer service life. So big versus small. That is all for today's SSD specs talk. If you have any questions about hard drives, drop them into the comment section below. We'll see you in the next one.